So the grid below shows triangle ABC and triangle DEF. Let A prime, B prime, C prime be the image of triangle ABC after a rotation about point A, which is right here. Determine and state the location of B prime if the location of C prime is 8, -3. So I'm going to first start by plotting C prime, which is over 8, 1, 2, 3, 4, 5, 6, 7, 8, and down 3. 1, 2, 3. So I want you to look from C to C prime through A. How did we rotate C so it maps onto C prime if our center of rotation is at A? You should notice that it's a 90-degree rotation because it forms that little 90-degree angle. So there's a 90-degree rotation about point A, and we went in the counterclockwise direction. So I'm just going to erase that stuff for now. Okay, so if we know it's a 90-degree rotation in the counterclockwise direction, we need to think about what forms 90-degree angles. We should remember perpendicular lines do. So perpendicular lines form right angles, which means we have negative reciprocal slopes. So if we need a plot point B prime, then I'm going to count from A to B and figure out my slope. It's down 1, 2, 3, 4, 5, right 1, 2, 3, 4. So my slope of AB was down 5, right 4. So my perpendicular slope is going to be up 4, right 5. Remember, we switch and negate. So from A, I'm going to go up 4, 1, 2, 3, 4, and right 5. 1, 2, 3, 4, 5. And call that B prime. From here, I can connect my triangle. So the question states, what is the coordinate of B prime? So B prime is at 1, 2, 3, 4, 5, 6, 7, 7, 1. We knew B prime was at 7, 1 because the angle of rotation was 90 degrees in the counterclockwise direction. Okay. The next question says, is triangle DEF congruent to triangle A prime, B prime, C prime? So when we see congruency, we are thinking either translation, a rotation, or a reflection. So look at triangle DEF and triangle ABC. We should notice that D has to map onto A, F has to map onto C, and E should map onto B. You should notice that a reflection took place. So we know the reflection, the line of reflection is in the middle of A and D because it should be equal distance. So let's try to figure out where the line of reflection is. There's 1, 2, 3, 4, 5, 6. So we're placing it 3 units away. So our line of reflection is at x equals -1. So are the two triangles congruent? Yes, because a reflection at x equals -1 is a rigid motion and rigid motions. Preserve angle measurement and side length. For number 34, I know we've done in class before, so we'll go over this one quickly. So we have a movie is projected onto a large outdoor screen. The bottom of the 60-foot tall screen is 12 feet off the ground. The projector sits on the ground at a horizontal distance of 75 feet from the screen. Determine and state to the nearest tenth of a degree the measure of theta, the projection angle. Okay, so whenever we're given triangles with angles, we're going to look for a right triangle so that we could use trig. So if our goal is to get the angle theta, look at the triangle that it creates. That angle is not creating a right triangle, so let's try to manipulate our picture to create a right triangle somewhere. So let's think holistically. If we locate this big triangle right here, we can create a big angle. So I'm going to call that angle X, that big angle. So looking at the side opposite, we have 60 plus 12, which is 72, and we have an adjacent side. So that's tangent. Tan of X is equal to opposite over adjacent. And when we're looking for the degree, we're going to use the second key, which is our inverse. So X is equal to the tan of -1, 72 divided by 75. So make sure we are in degree mode. So I'm going to hit mode, go down, and do you see how it's blinking on radian? I'm going to go over to degree and hit enter. And then I'm going to go back and do second tan, because I need the inverse, and I'm doing 72 divided by 75. And I have 43.83086.067. Remember, I want to write that entire number down. So X equals 43.83086.6067. Okay, the next thing that I want to do is try to find another right triangle that will help me figure out that angle. So I'm going to look at this little triangle right here and call that baby angle Y. So then I'll have an opposite and an adjacent still. So the tangent of Y is equal to opposite, which is 12, over adjacent, which is 75. And I'm going to do the same exact thing. Tan of -1, so the inverse is equal to 12 divided by 75. I'm going to type that into the calculator. Second tan 12 divided by 75 and hit enter. And my angle is 9.0927, etc. So Y equals 9.09027 and whatever the rest is. Okay, so if I'm looking for this little angle in here, and I have a big angle and the other little angle, I could just subtract angle X minus angle Y to get theta. So 43.83086.067 minus 9.09027. So I'm going to scroll up, highlight that, hit enter so I don't have to write it over, minus, scroll up, highlight that answer that I want, hit enter. And my answer is 34.7405. 34.0 Oops, just kidding. 34.7405. But my question says to the nearest 10th of degree. So that's the first number after the decimal. I'm looking at the second number. It's less than 4, so I'm going to, less than 5. So I'm going to keep it as is, 34.7.